So we have this, well, this is in the page from your booklet, in the page 45, if I'm not mistaken. Yes, page 45, okay? If you want to keep your booklet with you. So this is said to be naming ionic compounds with transition metals, which is known as the stock system. It is the topic that I've been explaining you this week, okay? Where we use the Roman numerals. Some elements, such as iron, okay, form two or more cations with different charges. Remember, where do we see the charges? There are two ways to see the charges, okay? If I give you the
In the periodic table.
exactly, in the periodic table, you can see the charges in the periodic table, or if I give you the ions directly, you can see the charge of the ion. For example, Fe2 plus is gonna be iron 2. Why? Because the charge is being indicated here in the upper part, okay? So in this situation, it is very easy to identify the charge that the cation is using. So this system, in order to distinguish those ions, we're gonna be using Roman numerals. This system is called as the stock system. Anytime we use the parentheses and the Roman numerals, that is called the stock system. And this system uses Roman numerals to indicate the charge of the ion. The numeral is enclosed in parentheses, and it is placed immediately after the name of the metal. So, for example, you can see that iron forms two different kinds of ions. To identify which iron is the one that we are using, we're going to specify the charge. In the first one, it's going to be iron, and immediately after, in parentheses, you will put the Roman numeral to represent 2, which is the charge that is indicated, okay? It is the charge, it's not the subscript. While checking the quizzes, I noticed that some of you still don't get the idea of this topic. That's why I am reviewing. Now, are we going to redo a quiz? Because no, we're not, okay? The idea is that you actually know how to do it, even though you did it wrong in the quiz. We have this exercise over here, iron 3 plus. So following the idea of the stock system, it's going to be written as iron, and in parentheses, you will write the Roman numerals. Now, remember, not all the metals will have the Roman numerals. For example, cations that form only metals, okay, that form only one cation, such as sodium plus, or barium 2 plus, or aluminum 3 plus, okay, those are, if you check for them in the periodic table, look for them, okay? Sodium is number 11, barium is number 56, and aluminum is, I think it is 13, okay? Look for them in the periodic table, and you will see that the only valence electron that they have is the one that they are showing. For sodium is plus, or just 1. For barium is 2 plus, or just 2. And for aluminum is 3 plus, or just 3. No other valence electron, okay? So when this occurs, when metals have only one valence electron, you are not going to indicate the charge in parentheses. So this topic, that's why it is said that is used with transition metals. Now, not all the transition metals need to be indicated the charge in the Roman numeral. No, only those transition metals that have multiple charges. So it is important that you keep these tables with you. This one table is some common monoatomic ions. I think I sent it to you already. Okay. It is important that you have it with you. Now, in this table, you will notice in the bottom part of it, it says D block elements and others with multiple ions. So take a look over here. You can use the periodic table for this purpose or not, whatever you prefer. Okay, I prefer to use the periodic table because there I have everything. But if you prefer to use these other tables, it's also nice. So notice that lithium, sodium, potassium, rubidium, and cesium, all these elements are from the group 1 of the periodic table. And none of them have the charge indicated in Roman numerals. That means that all those elements from that group, they're not going to show the charge in Roman numerals. Same happened for the group 2, starting from beryllium, magnesium, calcium, strontium, and barium. All these elements, they're never going to show the charge in Roman numerals because they have only one oxidation number that is +2. Now, in what elements are we going to indicate the charge? In those that have multiple charges, such as copper. We have copper 1 and we have copper 2. You can see that all of them are located in different positions. Okay, this one with a charge of 1+ and copper 2 with a charge, of course, of 2+. But we can say the same thing about some other elements, like chromium, for example. We have chromium +2, we have chromium +3, okay? We have iron 2, we have iron 3, we have cobalt 2, cobalt 3, okay? We have lead 2, lead 4. So this table is very useful because these elements are very popular, okay? So you're gonna have multiple exercises including these elements, but they're not the only ones, and that's why you can use your periodic table. Now, notice that silver doesn't have the charge indicated the Roman numerals. Also, zinc or cadmium, because these elements, if you look for them in the periodic table, they don't show another charge just +1 or +2. They have only one charge. So they don't need to be specified in Roman numerals what is the charge that they are using, because it's always going to be silver +1, zinc +2, or cadmium +2. In the page 45, you have a practice, okay, that it includes 15 exercises. Write the name of the following ionic compounds with transition metals by using the stock system. Now, one way to know, okay, one way to know is doing a procedure that is called oxidation number. But first, I'm going to show you the easy way. The easy way is to know which nickel is this, or which iron is this, okay? There's an easy way to do this. Recall that whenever we form a compound, recall that whenever we form a compound, what we do is basically we just exchange the position of the charges. That means that the 2 that is coming from iron is going to be after nitrogen, And the 3 that is coming from nitrogen is going to be just after iron. And this is the compound formed. To know what the charge iron is using, imagine that you don't have this anymore. You just have the compound. So to know what is the charge that iron is using, all you have to do is check the subscript of the anion. In this case, nitrogen has the anion 2, which indicates that this 2 is coming from iron, okay? In other words, what I have here is iron 2. And then I just write the name of the anion. Because it's nitrogen, I know that this is not going to be nitrogen, it's going to be nitride. Iron 2, nitride is going to be the name of the compound. I will do the same with the rest of the examples. Now, wait. Yeah. Okay. So let's work with the first example. As I'm telling you, one key, but it's not the only key, okay? But one key is to see the subscript of the anion. Nickel is a transition metal with nickel, okay? Not nitrogen, nickel. Nickel, don't forget. You have a I was noticing in the quiz that you have a problem with nickel and palladium. Nickel and palladium, better study those elements. PV is lead. PD is palladium. Just N, nitrogen, and I, nickel. Please don't forget. They're wrong anyway, but I'm just telling you not to forget. It's very painful to take points away for something that simple. You know, you were using the periodic table, so no excuses. Anyway, the easy way is to recognize or to identify what is the nickel that is part of this exercise, to name it. I'm just gonna take a look to the subscript. The subscript is 2, the subscript that is in the anion, okay? The subscript is 2, and remember that this one is coming from the cation. That means that my cation's name is gonna be nickel, and the charge specified is gonna be 2. So in other words, this will be nickel 2. Now, because my second element, my anion is bromine, then this is gonna be just bromide. Nickel 2 bromide. If you say that it's just nickel bromide, incorrect. If you say nitrogen 2 bromide, ooh, that is so wrong, okay? So don't mess it up on that one. Now I'm gonna do this after, okay? The number 2 is gonna be the last one that I will do of all these exercises. Now I will focus on the number 3. To know which iron is this, I know that iron is a transition metal. So I will notice the subscript of my anion. This 3 is coming from iron. Therefore, this is not just iron. This is gonna be iron 3. And then my anion, oxygen becomes oxide. Remember that oxygen is a special root that is just ox and then IDE because it's a binary compound. Take a look to the example 4. Is tin a transition metal with multiple charges? Yes or no? Guys?
Yes.
Yes. So you need to specify the charge. To know the charge, you see the subscript that is in the anion, which is chlorine. Okay? The subscript is 4, and that tells me that it's not just tin. This is tin 4. Okay? And then the name of the anion, which in this case is chloride. Chloride. The root and IDE. Please, chloride has an H after C. Okay? If you forgot the H in the quiz, that is incorrect as well. You need to be very careful. Let's do the next example. Now, is lead a transition metal with multiple charges?
Yes.
Yes.
Yes. So I'm gonna notice that the subscript. The subscript indicates that it's 4. Okay. So I know that in this case it's gonna be lead 4. Remember that we indicate the charge. We don't indicate the subscript. So this is gonna be lead 4. And again, chloride. And if you are clever, you notice that I missed one exercise, the number 2. Even though, I mean, it is highlighted that I need to do it. Now this one, the number 2, I'm gonna work with it separately. The one that says fail, okay? And I took it apart not because it's fail, it's because this is a very particular situation. Exercise 2. I know already that iron has multiple charges. So if I just follow the idea that I gave you, that just to take a look to the subscript of the anion, okay? If I follow the same principle of taking a look to the anion, I would say, because it's invisible, that this is iron 1 oxide. Okay, because the 1 is invisible. That will be my guess. I mean, if I follow the same idea, this is gonna be my guess. Okay, because this invisible 1 is coming from iron. But what happens? Do you think this is correct or not? Do you think this is correct or not?
I think that it's not necessary to put the Roman number.
It's incorrect, miss.
It cannot be correct for, well, several reasons. Let me read the chat because I noticed some messages. It's not correct. Okay. So it is true. It's not correct. Okay. If you do this, it's gonna be incorrect for 2 reasons. The first reason is iron can be only iron plus 2 or iron plus 3. Iron 1 does not exist. Okay, so if you say that this is iron 1 only because the subscript of oxygen is invisible 1, that is incorrect. So what happened here? Why is this so different? Now, Recall that oxygen is an anion that is called oxide. And the charge is always -2. So what happened with the -2 of oxygen? I mean, if I have to write it, oxygen will be oxygen -2. And if I combine, okay, I have two possibilities of combination. I can combine iron +2 and iron +3 with oxygen. So what happens here? In the first one, according to the idea that I gave you the other day, is when the charges are the same, but they have different symbols, these charges are canceled out. So what do we get as a result? We just join the elements. Now, if I had iron 3 with oxygen -2, in this case, I would have to crisscross the charges, and then the compound form will be iron 2O3. From the two, which one corresponds to the exercise? 1 or 2?
2.
Which one?
One.
One.
The first one, okay? As you notice in the first one, after I combine iron 2 with oxygen, I got fail, okay? So with this, you notice that it's not possible to have iron 1. This one is not iron 1. This one is iron +2. Remember, we only have two possibilities for iron that are right there in the periodic table. Only +2 or +3. Iron 1 does not exist. And with this, you can actually see what is the iron that we are using. Okay? The charge of this iron is +2. Therefore, the name for this compound should be iron 2, and then, yes, oxide. So, can it be wrong because you wrote iron 1 oxide? Yes, it's gonna be wrong if you write it like that. Also, because imagine that we had that actually iron 1 would exist. Imagine that it's possible to have iron +1. So you combine this with oxygen. So you will have this. And this compound is totally different to the one given. So it cannot, I mean, there are so many reasons why that is incorrect. So just to finish this part, how can we name this compound over here? Which iron is this? Iron 2 or iron 3?
Iron 2.
You see iron 2 over here, but this 2, remember that this is 2 is coming from oxygen. So the number that tells me what is the charge of iron is the number after oxygen. The last number is gonna tell me the charge of the first one. So this has to be iron 3. And then the name of the anion, that is oxide. Sorry. So I'm gonna write you another example. If I had to name this compound, if I have to name this compound, first I have to see what are the possibilities for lead. What are the possible charges that lead can have? Aha. 2 and 4. And this is a very tricky exercise, so you better pay attention, okay? Take a look. If you had to name this by following the idea that this 2 is coming from lead, you might think that the name of this compound is lead 2 oxide. Are you agree that that is lead 2 oxide? This is a tricky exercise, okay? And I'm showing it to you for a reason. And I'm showing this to you because it's not lead 2 oxide, even though that 2 that is after oxygen might represent lead. That one is incorrect. This name is incorrect. Remember that I said at the beginning that lead can form +2 or +4. And I'm combining this with oxygen that is always -2. So in the first one, I have lead 2 combined with oxygen 2. If I follow the idea, okay, they will be canceled out. So the compound formed is PbO. Does PbO correspond to the exercise given? Is
No.
this the same compound that I showed you in the beginning? It's not, okay? So, because it's not the same compound, we cannot say that this is lead 2 because lead 2 forms this compound with no subscripts. So I'm gonna try with my second possibility for lead, that is lead 4. When this occurs, we need to crisscross the charges and the compound formed will be lead, that 2 that is coming from oxygen, and the 4 that is coming from lead. But remember this, sometimes we need to simplify the subscripts. Can we simplify these subscripts? 2 and 4 can be simplified? Yes. Both are divisible by 2. So to simplify, the compound form will be PV. Okay, we have 2 and 4. So that 2 becomes 1 and the 4 becomes 2. Okay, so PV1O2. And remember that 1 is invisible. Is this compound the same compound that I gave you initially?
Yes.
It corresponds the first exercise, okay, the exercise given. So now, because it is the exact same compound, I'm gonna see the charge of the lead, and now I'm able to name it. So this is not lead 2 oxide, instead is lead 4. 4 in Roman numerals is written like this, not the 4 thalys, Okay. Not the Fortalis that I saw yesterday from someone that I won't mention the name. So lead 4 oxide. So it is very tricky. It is very tricky. But that will happen only with charges that can be simplified. So you need to be attentive on that. For example, if you are combining with anions that have a charge of -1, in that case, you will never simplify. Just be attentive with oxygens or nitrogens or sulfurs, okay? But yes, that particular exercise is pretty much complex, because if you follow the idea of just taking a look to the subscript, then it's gonna give you the wrong name. So chemistry is nice, but it has so many exceptions and you need to be careful for so many reasons. I'm gonna need that you finish the page 45 as a homework, okay? Homework, complete page 45. Okay,
Miss,
so
I had a question.
uh-huh.
How do you know when you had to simplify?
When the subscripts are divisible by the same number. So for example, if you had okay, yeah. If you have, for example, manganese 4 and oxygen 2, you will form the compound. It will give you Mn2O4. In this case, 2 and 4 are both divisible by 2. Or in the other hand, you could have the other example that I remember is this moment is chromium plus 6, and I will combine with phosphide. So charala charala, cross the charges, you will have chromium 3, phosphorus 6. 3 and 6 are another pair of numbers that are divisible. In this case, they are divisible by 3. So you will divide each subscript by 3, giving you